Hello, everyone. My name is Mete Atamel. I am a developer advocate at Google, based here in London. It's funny, I live in London, but I spend most of my time outside London, so I always give talks in different places. So it's good to give some talks in London as well once in a while. This is my Twitter, Mete Atamel. I already gave this presentation 2 days ago in CodeMotion in Amsterdam, and I already have these slides tweeted. So if you want to get the slides, just follow me and you will have the slides. So what we're going to do is, my talks, they usually have the same pattern. I always start with the question of why, and then I go into what, and then I explain how. The reason I do that is that there's a lot of things to learn nowadays. Technology is changing really fast. So I think it's really important to answer the question of why you should even care about a piece of technology. So in the first part of my talk, I will first give you a little bit of background with containers and Kubernetes, because Istio depends on these, so everyone is on the same page. Then we'll talk about what is Istio at the very high level. Then we'll get into details of Istio, or Envoy, Mixer, Pilot, Istio Auth. Then we'll look at some of the add-ons like Grafana, Prometheus, Zipkin, and Service Graph. And finally, we'll wrap it up with traffic management. One of the coolest things about Istio is that you can actually set rules about how the traffic flows in your microservices cluster, and you can change those rules on the fly. And I think that's one of the most powerful things about Istio, so we'll take a look at that. I will try to do a live demo, but sometimes with Wi-Fi and everything, things don't work. So if not, then I have backup video, so we'll see how that goes. All right, so first let's talk about containers and Kubernetes first. I feel like 2 or 3 years ago, everything was about containers. We were all talking about Docker and containers and stuff like that. And then last year and the year before, it was more about Kubernetes. And especially last year, I think Kubernetes made a big impact, and now it is kind of like the de facto standard in container management platforms. And this year, I feel like since we solved the problem with packaging with containers and container management with Kubernetes, we are moving beyond that. So Istio, to me, is like the next thing in the pipeline after containers and Kubernetes. So before I talk about Istio, I just want to briefly, just couple of slides on containers and Kubernetes, just to make sure that everyone is on the same page. But before I start, who is working with containers today? Who is deploying code with containers? Yeah, so almost everyone, not surprising. 2 years ago, it was like a couple people. Last year, it was more people, and now it's even more. But what is a container for those of you who might not know still? A container is nothing more than a way to virtualize your application. But the key thing about containers is that it's lightweight. So before containers, we had virtual machines. So the idea of virtual machines is that you virtualize the whole operating system and everything that goes on top of that. So that was also a way of virtualizing your application. But the problem with virtual machines was that it wasn't lightweight. It was quite heavy. It wasn't easy to create them. It wasn't easy to run them. It wasn't easy to share them. But the idea of containers is that instead of virtualizing the whole operating system, why don't we virtualize the process that our application runs, and also the environment, the context that our application needs. This way, you're virtualizing much less, and because of that, containers are much more lightweight than virtual machines. They're sealed and isolated, meaning you can have multiple containers running on a single operating system. They're very easy to deploy. They're very easy to introspect, so you can actually get into the container and you can see what's happening as if it's a virtual machine, but it's not. And for me, the biggest thing about containers is that they're composable. So you can create an image for your application that can depend on a base image, and then someone else can come along and get your image and build their image on top. So you can layer these dependencies, and each layer is individually cached. So if 2 images depend on the same base image, the base image is downloaded once, and they can be shared with different containers. So that's what a container is. And Docker, all it did is basically Docker made containers easy to use for everyday developers. The ideas of containers, they've been around in Linux for a long time. And at Google, we've been using containers for more than 10 years. But they weren't so easy to use for everyday developers. So Docker, they created this notion of Dockerfile. In Dockerfile, you define your dependencies, you define your environment, and you define your application and how it runs. So for example, in this case, this is a very simple Dockerfile where we are depending on the latest version of Debian, so that's our dependency. Then we're installing some packages, in this case Nginx, and we are exposing port 80, so we are setting up our environment. And then we have a command line where we are just running Nginx with certain options. So in this single file, we are defining our dependencies, our environment, and how our application is running. And Docker, all it does is that it reads this and it makes sure that this context that you're creating for your application is run exactly the same way everywhere. So the way that you run this on your laptop, it will be the exactly same way the way you run in the cloud. So it gives you the context that you can guarantee that it's always the same. So that's what containers do. But containers by themselves, they're not enough, right? When you run an application in production, you need just more than a context. For example, you probably need redundancy. So you need to run multiple copies of your containers, and you need to manage them. You probably, at some point, you need to scale up. Because if you have containers and if more people are using them, you probably want to scale up. And then maybe in the evening, less people use it, so you want to scale down. So you need to manage that scaling up and down. You probably want to have some kind of rolling out and rolling back. So if you have a new version of your application, you need a way to upgrade your containers in a consistent way. And if something goes wrong along the way, you want to be able to roll back to a previous version. You want to have resiliency. So how do you even know that your container is resilient and it's running and everything is working? So you probably need like a health endpoint where you check what it means for your application to be healthy, and someone has to check that health endpoint and make sure that that application is actually running. And if not, take some action. And also configuration of secrets. How do you define configuration, and how do you get that configuration into your containers, and how do you manage that? So there's all these things that you still have to do. Just because you took your application and created a container out of it doesn't mean that these problems go away. So that's why we have Kubernetes. What is Kubernetes? As you can see, it's a Greek word with the Greek letters. And it's a word that everyone mispronounces, by the way, because the right way of saying Kubernetes in Greek is Kybernetes, but Kubernetes came along in the US, and people in the US, they tend to mispronounce things. They know that, I guess, and now we are stuck with this mispronounced Greek word. But basically, Kubernetes, it's a 100% open source project. It's written in Go. It came from something called Borg. So as I mentioned, at Google, we've been running containers for a long time, and we created an internal container management platform called Borg. So that's what we use to manage our containers internally. And people who worked on Borg, they learned from it over the years, and they created Kubernetes for everyone else. So it's not based on Borg in terms of code, but it's based on the learnings from the Borg. And for me, the greatest thing about Kubernetes is that it runs everywhere. So it can run on your laptop, it can run in multiple clouds, AWS, Azure, Google Cloud, and it can even run on your own machines in your own data center. So it's one of the few technologies where there's broad support from all cloud providers. And so once you adopt Kubernetes, basically it becomes your choice to choose where to run it. You can run it in your own environment, you can run it in any cloud you want. So it's a good technology like that. So in this containerized microservices Kubernetes world, a microservice looks something like this. It's a little bit different than what we are used to. First, you have your code, but you have to containerize your code. So you take your code, containerize it, and put it in a container registry. This can be any public container registry, either Docker Hub or Google Cloud Container Registry. But either way, your code lives in some kind of container. Then from there, there's this notion of pod in Kubernetes. A pod is the smallest unit that Kubernetes schedules. Usually it contains one container, but it can also contain multiple containers. So you create this pod template, and from then on, you tell Kubernetes what you want to be true. In this case, for example, we have something called replication controller in Kubernetes, and we are telling replication controller we want 3 replicas. This means I want to run three copies of my pods at all times. And what replication controller does is that it will use a template, create your pods, and it will schedule them on the nodes that you have. So you have some nodes. In the cloud, these are virtual machines, but in your own environment, these are physical machines. Basically, the replication controller will figure out how to create these pods and how to schedule them wherever it makes sense. This scheduling problem becomes Kubernetes' problem, not your problem anymore. Once your pods are running, you can label them with different kinds of labels, like role or environment. And then once you are ready to expose your pods to the outside world, you create something called service. A service is kind of like a load balancer for your pods. It has a stable virtual IP, and people from outside will get to the service, and from the service, it will get to your pods. So in this new containerized world, a microservice is not just your code anymore. It's your code via the container, but also what Kubernetes provides in terms of replication controller, creating your pods and watching your pods. And if something goes wrong with these pods, if one of these nodes go down, then replication controller will detect that and it will create a new pod for you. And then service will expose your pods. And there are many other things in Kubernetes that will help to make sure that your microservice is running. We won't talk about Kubernetes here because I have another talk that's 1 hour just on Kubernetes. But this is how things look like in this new world. But Kubernetes also is not enough, because when you write microservices, you need logging. So what logging framework do you use, and how do you keep track of logs, and where do you send them? You probably want HTTP tracing. So if you have multiple microservices calling each other, how do you keep track of what calls are being made and how long time is being spent? So you probably need some kind of tracing. It would be nice to do some kind of dependency visualization. So if you have microservice A calling microservice B, and microservice B calling microservice C, it's good to see that dependency in a visual way, and it's also good to see the metrics flowing through that visualization, and so that you get a better idea of what's running. You definitely don't want metrics, because when you have a complex system without metrics, you're going blind, so you need to keep track of metrics, and you need to send them somewhere, and you need to visualize them. You probably want to set some kind of traffic flow. So you don't want everyone to call each other, right? Like you want to set some rules where certain microservices can call other microservices, but not the other microservices. And once you set these rules, you want to make sure they're enforced, right? And you want to be able to change them easily. You probably want to do fault injection. So if you have microservices calling each other with certain timeouts and with certain kind of retries, you want to inject faults and see what happens. Do your microservices behave the way they are supposed to behave? So Docker helped us with the packaging problem and context problem. Kubernetes makes sure that the container runs. But all these problems that you should solve, ideally, in your environment, it's still your problem. So that's why Kubernetes is not enough either. So that's why we have Istio. So this is the logo of Istio. It's a ship. And the reason why it's a ship is that Istio means sail in Greek. The good news is that Istio is not mispronounced, so we are after a good start here. I guess it's much easier than Kubernetes for people to say. So basically, Istio it's just an open framework to connect, secure, manage, and monitor microservices. And we will look at what this means in detail now. Before I get into details of Istio, I want to outline the goals of Istio, and in my mind, there are two certain goals of Istio. First, Istio is about community maturing and gathering together around common tools. Because we all want logging, we all want tracing, we all think that service dependencies are good things to have, we all want metrics. So why do we have to reinvent the wheel every single time and try to figure these out for different projects in a different way? So what Istio tries to do is that it's community coming together and trying to find the best tools for the job and give you those by default. But at the same time, it tries also to be as extensible as possible so that if something doesn't work for you, you can plug in whatever you want. So it tries to give you the basics by default, but it also tries to be extensible so that people can plug in whatever they want. So that's number one. And the second thing is that it really helps with this problem of application code and infrastructure. So ideally, in an ideal world, your application code only deals with application problems. So it only solves the business problems, and it doesn't care about the actual infrastructure, right? But in reality, we know that's not true. In reality, most of the time, your application ends up having details of the infrastructure. So whether it's running on a VM, whether it's running in a container, whether it's being managed by Kubernetes, it kind of has to know that in today's world. But with Istio, I think we can really separate out application code from the underlying platform. And Istio kind of enables that, and we'll take a look at how that happens. All right, so let's imagine that we have this service architecture. Let's imagine that we have the users talking to a front-end microservice, and then maybe the front-end microservice is talking to an authentication service that's using a SQL database in the backend. Then we also have another pictures microservice that the front-end is talking to, and then maybe another microservice called payments that has a dependency to an external payments processor. So let's imagine that this is our microservice architecture. If you want to install Istio into this microservice cluster, this is how it looks like. So once you install Istio, the first thing that you'll realize is that we have something called ingress. So all the incoming traffic goes through something called ingress. Ingress is kind of like the gatekeeper to the microservice cluster. And then from ingress, you'll also realize that every pod, so every microservice lives in a pod. Every pod gets a proxy as well. So every pod gets a proxy as a pod, and all the traffic goes through the proxies. So from the ingress, to go to the front end, we'll go to the proxy of the front end, and if front end wants to call the pictures microservice, the proxy of the front end will call the proxy of the pictures, so on and so forth. Since the traffic is going through the proxies, then Istio can do a lot of interesting things, and we'll look at some of those shortly. So that's how things are. So things go through the ingress, we have the proxies, where the internal traffic happens, and also all the external traffic from your microservices to the outside world is by default blocked. So you cannot call anything outside. If you want to enable payment service to call an external payment processor, then you have to actually create something called egress rule and enable that, and then payments can call the external rule. This is by design because by default we don't want people to call external services whatever they want. We want them to tell us explicitly that they want to call an external service, and then that will be enabled and you can call them. All right, so how do you get an Istio? Like, how do you get Istio manage your microservices? Well, first you need a cluster. In this case, I'm using Kubernetes cluster in Google Cloud. What I need to do first is I need to create a Kubernetes cluster. So in Google Cloud, you just say gcloud container clusters create, give your cluster a name. You don't need to do this anymore. I should fix this slide, so you don't have to do enable clusters alpha anymore. But you basically specify your machine types, your number of nodes that you want in your cluster, and you don't need this anymore. You specify your zone. So you basically just create a regular Kubernetes cluster. And then the only thing that you need to do special for Istio is this. You need to do a cluster role binding and give Istio basically some rights to manage the cluster for you. So there's nothing special. So you just create a cluster, and then you create a cluster role binding for Istio, and then you can use Istio in your cluster. That's all there is to it. So I want to show you how to install Istio. Let's see if the live demo is going to work. So first I want to show you this. So here I am in Google Cloud. By the way, who is using Google Cloud as projects at work? Yes. And who is using it as a hobby or anything or something like that? Okay. So more people are using it for hobby. Maybe next year will change. We'll see. So here I am in Google Cloud Console, and in Google Cloud there's a bunch of different things like App Engine, Compute Engine, but we'll look at Kubernetes Engine. This is basically Kubernetes cluster managed by Google, and in here you can create a cluster, and you can specify. I'll just show you briefly how this looks like. You can basically specify your cluster name, your zone, which zone is supposed to live, what version of Kubernetes is supposed to use, and then how many nodes you have in your cluster. The master node is managed by Google, but this worker nodes is yours, and you can schedule containers here. So I already created a cluster called Hello Istio that has 3 nodes. So I'm just going to install my Istio into this cluster. So right now, this is just a regular Kubernetes cluster. There's nothing special about it. So what we're going to do is, so by the way, there's something called Cloud Shell, which is a shell that you can use in the browser. So you can use that as well if you want, but I want to use my command line because it looks, the fonts are a little bit prettier. So let's make this bigger. First thing that you need to do is you need to install Istio. So to do that, you can use curl. I already did this because I didn't trust the Wi-Fi of the conference, even though it's really good. But just to type it out for you. So basically, if you do this curl command, you will get the latest Istio, which is 0.7.1. And once you have that, then you're going to have this folder. And then in this folder, just to show you briefly what we have. So this is the folder. And under bin, there's something called istio-ctl. This is the command line tool to manage Istio. Just like you use kubectl to manage Kubernetes, there's istio-ctl to manage Kubernetes. So you usually add this to your path so that you can call it from anywhere. The install is where the installation scripts for Istio is. So you can install Istio to GCP, you can install it to Kubernetes. So there's all these YAML files for different kinds of installations. The one that we're going to look at is Istio auth. So in Istio, you can install, I show you the proxies that make the communication, right? Those proxies, they can have mutual authentication enabled, or you don't have to have that as well, so that they can be just not mutually authenticated too. Istio auth installs Istio with mutual authentication. So that's what we're going to look at. And if you look at this YAML file, I mean, we don't have to go into details because it's a lot of stuff, as you can see. It installs a lot of things. I think they should fix this in Kubernetes world. All these YAML files, it's a lot. There should be a better way of doing this, but anyway. But this is the YAML file that we'll point to, and this will install Istio for us. And then under samples, there's some bunch of like hello world kind of samples for Istio. We're going to look at the book info sample. So this is a simple microservices cluster that we'll take a look at to understand some of the features of Istio. So OK, that's all I want to show here. Maybe I will keep this open for later. And what we're going to do is first, let me see if I have Istio-CTL in my path. Yes, I do. Is this big enough? Let's make it a little bit bigger. So to install, I will say, first of all, if I do kubectl get deployment, we see that there's nothing in my cluster. And to do it, I'll just say kubectl apply -f install Kubernetes Istio auth. So I'm just pointing to Istio auth, and this goes through the YAML and creates all the resources that we need for Istio. And you can see that it's quite fast. So now if you do kubectl get deployment, oh, there's nothing. The reason is Istio installs into a separate namespace called Istio system. So everything lives under Istio system. So we need to do this. And then we can see that there's Istio CA, which is certificate of authority. There's ingress, there's mixer, and there's pilot. And we'll look at what these are. But by default, things are installed. And the good thing is that it's in a separate namespace. So if I want to remove Istio, I just remove it, and then it will just remove the namespace, and everything still works in your cluster. So that's the deployment. Let's look at the pods system, and the pods are running as well. So, and then if we look at the services, we have services as well. And the Istio ingress is the one that we're going to use to get into our cluster. So that's how we install Istio. Let me see. I want to go back to presentation. So it's just pointing to a YAML file and letting it to install in your cluster under the namespace, and you're good to go. So what does Istio give us? That's a lot of things to go through, but just briefly, first of all, Istio is supported on multiple platforms. I'm going to show you on Kubernetes, and it's the first platform that it tries to support, but it aims to support Mesos and Cloud Foundry and other platforms as well. So it tries to be platform agnostic as possible. It gives you a lot of observability features, so metrics, logs, traces, dependency visualization, all the things that you need when you run an application in production. It tries to give you metrics, observability features for that. It gives you service identity and security, so every service will have an identity that can be verified, and you can also enable service-to-service authentication, so to make sure that your service is being called by the right services. It gives you a lot of features for traffic management, so you can set rules on how the traffic flows in your system, and those rules are enforced by Istio without you having to change anything about your code. And there are rules at the ingress, so whatever comes into your system. There are rules on the egress, so nothing is allowed by default, but you can set rules to allow things. And then you can set rules in the system as well. So if you have multiple microservices, you can define who calls what and who's allowed to call what. And you can also set quotas. So you can say this microservice can call that microservice, but it can only call it, like, say, 5 requests per second. And if it's more than that, it will enforce that. And finally, policy enforcement. I talked about this. Basically, all the quotas you set, Istio enforces those for you without you having to do anything special. So that's what it is in a single slide, what kind of stuff Istio gives you. And in terms of building blocks, so at the very high level, this is how an Istio-enabled microservice looks like. So first we have the front end, that's our microservice. When it gets created, a proxy also gets created along with it. And same with the payments, a proxy will get created with it. And all the traffic between these microservices, it happens through the proxies. So proxy is the thing that does the work. So you can use HTTP1, HTTP2, or gRPC. For those of you who don't know, gRPC, it's a binary protocol that came from Google, but it's open source now. So you can use that, and you can use with TLS or without TLS. So all the communication happens through the proxy. Then we have the control plane. So the control plane, these are the things that kind of help the proxies do their job. Basically, that's their role. For example, Pilot, it's about discovery and configuration. So proxy, when one proxy wants to call the other proxy, it will ask the Pilot, where is this other proxy? So it will ask for service discovery to the other proxy. And if you want to configure the proxies, as a user, you will talk to the Pilot, and the Pilot will convert that rule to proxy rules. So that's what the Pilot is responsible of. Mixer is all about policy checks and telemetry. So if this proxy wants to call this proxy, it will ask Mixer, can I make this call? Is there a rule that I should be aware of? And Mixer will say yes or no. And also, all the telemetry information will go from proxies to the Mixer, and Mixer will then display them in add-ons. And Istio Auth is all about TLS, mutual authentication between sidecars. So at the high level, this is what Istio looks like. And to let you know, this proxy is called Envoy. It's a project from Lyft that does everything, basically. Load balancing, TLS termination, HTTP2, gRPC, health checks, circuit breaks, metrics, all that kind of stuff happens through the Envoy. So since all the traffic goes through these proxies, there's a little bit of overhead because it's another hop, but it's supposed to be really efficient. And I heard that Lyft run these envoys on 10,000, I think, virtual machines, and millions of requests go through these envoys. So they are really highly tuned, and they try to introduce minimal impact to your calls. And Pilot, we already talked about this. It's all about service discovery and rules. And one thing that I want to mention about Pilot is that it's a good abstraction point for the users and for proxies as well. So for users, you talk to the Pilot and you set rules about what you want to be true, and the Pilot will take those rules and it will convert those rules to the platform-specific rules. So, for example, if you're running on Kubernetes, it will take the rules and it will convert those rules to Kubernetes rules. But if you're running on Mesos, it will convert to Mesos rules. So it makes users unaware of the underlying platform through the rules API. At the same time, the proxies, the envoys, when they want to discover other envoys or when they want to know about the other traffic rules, they will talk to the Pilot through the Envoy API, and the Pilot will ask the underlying infrastructure, in this case Kubernetes, to figure out where the other envoy is. So this way, the envoys, they don't have to care about where it's running. They will just ask the Pilot, and Pilot will do all the translation. So Pilot is kind of like through the adapters, it's kind of like the point where Istio becomes kind of platform agnostic through these adapters. And Mixer, I talked about this already. Precondition checking, quota management, telemetry reporting. I put these here so that when you have the slides, you can read through them. It's useful for some people. And Istio Auth is all about mutual authentication between proxies. So if you enable that, then Istio Auth is the one that will manage that for you. All right, so what I want to show you now is a sample application that comes with Istio. And in this sample application, we have a front end called product page that's written in Python. And this product page will talk to other microservices. So one of those microservices is called reviews page that's written in Java. Then there's going to be another microservice called details that's written in Ruby. And there's another microservice called ratings that's written in Node.js. A couple of things to note here. First, we have multiple microservices written in multiple languages, but this is okay in a container as well, because as long as you can put these things into containers, no one cares how they are running. That's the beauty of the containers. And the second thing is that some microservices, they have multiple versions. So in this one, the reviews one, there's reviews version 1, reviews version 2, and reviews version 3. Initially, Istio will load balance between them two, between the three, but after we'll pin our versions to a specific one so that we can look at how traffic rules work. So that's the app we're going to look at. So to deploy the app, I will come back here. And so let me type this first. So let's first of all, let's make sure that Istio is still running, so the pods are running. Yeah, the pods are, so Istio is running. Now I want to deploy an app, and to do that, I'll just say, normally, what you would say is that you would say kubectl create -f, and then you'll say samples bookinfo kube bookinfo.yaml. So you, there's none. Let's see. Oh, bookinfo. Yeah. So normally you would do this. But what I want to do is that I want to make sure that every time a pod is created, a proxy is injected with it. So there's a proxy that comes along with every pod. So to do that, I will just add this. So I will do this, and I'll say Istio ctl kube inject, and then -f, and I think I need, yeah, I think that should be it. So this way, when these pods are created, we should also see the proxy that's being injected with every pod. So if we do this, and if you say kubectl get pods, now you see that the details, product page, ratings, and reviews are being initialized. But you also will see that there's 2 for each. And the reason is, there's one pod for the actual microservice, but the other pod is for the proxy that's being created right now. So if you do it again, then they're running. Great. To get to our product page, we need to go through the ingress. So to get the ingress IP, I need to run a command. I don't remember this thing, so I'm just going to copy and paste from here. So we did create this, and then, yeah, so we just need to do this. So this is the ingress IP. And if I copy this, and let's go here. And I think it's port 80 / product page. Yeah, this is the product page for the sample application. And one thing that you realize is that, well, first, this is product details. So this is talking to a details microservice. This is a reviews page, talking to a reviews microservice. But if I do refresh, you will realize that this reviews will keep changing because we have 3. Oops, it didn't. Yeah, sometimes it doesn't work. Okay, now it refreshed to red, and if I do another one, it's black. So because every time I do a refresh, it goes to a different microservice. But we'll fix that later. I think that's all I want to show here. Double check. Yeah. So that's how you deploy application. It's again like deploying like regular, except you add that inject command to inject the proxies. And because we have the proxies, now Istio is managing our traffic for us. Now, once you have the base Istio working, now you can add on stuff on top of it, right? Who is using Grafana here? So people know this. So if you want to visualize your metrics, you can use Grafana. There's an add-on for that in Istio. There's Prometheus to query the metrics. There's Zipkin to do HTTP tracing. So when you hit a product page, you can see like how much time is being spent and what's being done. And then my favorite is service graph. So you can see the graph of your dependencies. So you can see like there's an ingress, there's a product page, and all the different reviews and stuff like that with their requests per second as well. So to add this on, let's do that. So to do that, I'm just going to copy and paste. Let's see, where am I? OK, so I will say kubectl apply. So there's an add-ons folder with a bunch of add-ons. So first we need Prometheus. So let's do that. And since I'm here, I'll install them all. Install Kubernetes add-ons. Next one is Prometheus. Let's say Grafana. Zipkin. Service graph. All right. So that's how you add add-ons. And if I do kubectl get pods, Istio system. They're all running. Let's send some traffic to make sure that first I need to set the gateway URL. So this is I need to set this variable. So let's copy this. Come here. Oh. So I'm going to say export. I think I will gateway URL. Ooh, I didn't copy correctly, sorry. Copy this, come here. Yep, and then if I do, yep. And to send traffic, I have this script that I'm just going to copy and paste. Let's see if this is going to work. I need to get rid of these slashes. All right, now we are sending some traffic. I probably want more than 10, so let's make this 100. So as this is happening, first I want to look at Prometheus. So to look at Prometheus, I need to set port forwarding so I can take a look. So there's a command for this. So this basically sets up port forwarding from my machine to Prometheus so that I can take a look. So if you go 9090, let's open that up. This is Prometheus, and then if you want to look at some metrics, Istio request count, so that's one of the default metrics. You can see the results, and you can also see the graph. So that's like we have the basic metrics. One thing to keep in mind is that I haven't changed anything about my application. So this is all happening through the proxy. And since the traffic is going to the proxy, it's sending the metrics to Istio, and I can visualize it through the add-on, right? That's the key thing about Istio, is that you don't have to change your application for it. So that's Prometheus. If I want to look at the Grafana for visualization, I also have a port forwarding here. So that's 3,000. So by default, you get this Grafana dashboard, and then there's mixer and pilot dashboard. So this is for the mixer and pilot components of Istio. But the one that I want to look at is my cluster. So I'll look at Istio dashboard. And under here, I mean, most of you know what Grafana is. So you can see your services, and you can see all the default metrics with it. And this is for product page v1, and reviews default too. So you can get in all the details about that, right? So that's Grafana. And next thing I want to show you is Zipkin. So for that, let's copy this one. It's very hard to see from here. At 9411. So Zipkin is about HTTP tracing. So under here, I see different microservices, details, ingress, product page. So if you look at product page, find traces, then we already got some traces for our product page, and see what product page has been calling and how long the time has been taken. Again, this is done for us automatically without us having to change anything about our code. And last thing, and my favorite, is service graph. In service graph, let's set it up. $80.88. So there's a bunch of graphs. So there's like a simple graph, like dot graph, that gives you something like this. But I think there's 4 of them, but I want to look at this one. So this one tells us there's ingress, there's product page, there's details, and then reviews. And you can see the dependency on each. And if you click on one, you can get more details about the request per count. Yeah, so it's very useful to visualize basically what you have in your cluster. And I like it because it helps when you're debugging stuff. All right, so let me close this and go back to presentation. All right, and in the last part, I want to talk about traffic management. So right now, we got the base Istio working. We got the application deployed and managed by Istio. Then we got the add-ons for visualization and for service graph, stuff like that. And in the last part, I want to show you what kind of stuff you have for managing the traffic in your cluster. So in Istio, you can do things like A/B testing, rollouts, canary releases. There's like discovery and load balancing that comes with Kubernetes. There's failure recovery. You can use timeouts and circuit breakers, and you can use fault injection. So this is the kind of stuff that you can do with Istio when it comes to traffic management. For example, let's imagine you have a case like this, where service A wants to make a call to service B. It will simply make a call to serviceb.example.com. So it will just use a DNS name. But then this will go through the envoy, and the envoy will ask the pilot, where do I find this service? Because the pilot is the one who actually keeps track of the services. And then in pilot, you can set some rules on the traffic. So for example, you can say 99% of the traffic should go to version 1.5 of my application, but 1% should go to this other new version 2 of my application. So you can set a rule like that, and envoy will be routed to 99% of the time here, 1% of the time here. And this is done transparently from the service. The service doesn't know. It will always make requests to service B, but through envoy and through pilot, you will get this kind of A/B testing or canary releases, stuff like that. Or you can also look at headers. So you can say user agent Android header. If you have that, it can go to certain pods. But if you have user agent iPhone, for example, it can go to other pods. So you can set rules like that as well. And this will, again, be handled transparently for the service. And pilot, actually, it's the one keeping track of the services, but it relies on the underlying infrastructure. So in this case, if you are running on Kubernetes, then pilot will ask Kubernetes, where is this service? And Kubernetes has service discovery, and it will basically keep track of the services for you. So pilot is basically just asking the platform, where is the service? OK, I have a demo to show this, changing the routes. What I want to show you is first, if we come back here, maybe let's go here. This is better. So if I do istioctl, this is the command line tool for Istio. Yeah, it works. So if I do istioctl get route rules, there's no routes. I don't have any rules, right? And when I don't have any rules, if I go back to my application, do refresh, then this keeps changing, right? What if I want to set this microservice to a certain version and pin that to that version? You can do that. You can set a traffic rule that says all the traffic goes to a certain version and see if it works. So to do that, we can say istioctl create -f samples book info cube route rule all v1 YAML. So I'm basically pointing to a YAML file and creating a route rule of it. And we'll look at the YAML file. But what I'm saying here is that I'm setting all my services to version 1, all of them. So once I do that, and if I do route rules, I can see that they all default, the product page, ratings, reviews, they all point to a specific version. And if I come back here and do a refresh, then I'm doing a refresh, but this always stays the same because I set all the rules to version 1. And if you actually look at the YAML file, cube, what was it? Route rule all v1. So in the YAML file, you see that we have route rule, reviews, version 1, ratings, version 1. So that's how you set the route rule. So you basically specify your microservice and the version that it's supposed to have, and that's it. You can also do more complicated things. So you can pin certain users to certain microservices. So imagine you have a user called Jason, and you want to send them to a specific test version. You can do that. So let's try that out. In this case, I'm going to say Istio create samples, looking for kube, route rule, reviews test, v2. So this will set a certain user to version 2 of our application. And if I come back here, and so this is version 1, I think. So if I keep refreshing, it will stay to version 1. But then let's say I'm signing in as Jason, sign in, this changed to version 2. And if I keep refreshing, it will pin to that one. And if I log out, then it will go back to the other version. So this way, I can pin certain users to certain test versions. And if you want to get rid of these route rules, all you have to do is istio delete. So let's get rid of JSON rule, and let's also get rid of the other one we created. And if I do istio get route rules, now I don't have any rules. I go back here, refresh, and it's going back to the original case, right? So that's how you can easily dynamically change things in Istio. All right, what time is it? Okay, I have 4 minutes. In the last 4 minutes, there's also failure recovery things in Istio, so that you can set timeouts, you can set retries that can kind of change the retry with a random time. You can limit the number of connections, so you can say this microservice can call this microservice, but this many times, and you can limit the number of connections coming to your microservice. You can have health checks and circuit breakers, and you can do fault injection. So this is, for me, this is my favorite, one of the favorite features of Istio. So imagine you have a microservice calling another one, and you have a certain timeout, in this case 100 milliseconds and 3 retries. And in this case, this microservice is calling another microservice, but the timeout is 200 milliseconds with 2 retries. How do you test this? Usually, it's not easy to test this kind of stuff. But in Istio, you can actually inject faults, and you can say, for this connection, I want to have delay of 300 milliseconds and see what happens. And then for this connection, I want to add a delay of 400 milliseconds and see what happens. This way, you can test these issues that usually happen in the production much more easily with Istio by setting these special rules and just running the test, see if it works. And then when it works, you can delete the rule, and you're back to normal. So that's the good thing about Istio. But after seeing all this, if you say, this is good, but I don't want to use Istio, it's very easy to get rid of. So in here, for example, now I have kubectl get pods Istio system. If I want to get rid of Istio, I just say kubectl delete -f install Kubernetes Istio auth. And now I'm deleting Istio from my cluster. And since everything is living under the same namespace, it will be, well, ignoring the errors. I think it should be fine. Then everything is terminating, and within a few seconds, we should see Istio gone, right? So it's that easy to add and remove from your cluster. Let's see if I have anything else. Cleanup, we did that. Yeah, and all these steps that I told you about, I blog them on my blog. So if you want to try them out yourself using Minikube, Minikube is the version of, like, it's basically running Kubernetes locally on your laptop, so you can follow those steps and install Minikube and run these steps yourself and see that it works. And if you want the slides, that's my Twitter. Yeah, that's all I have. Thanks very much. I think we have 1 minute, so maybe I can take one question if someone has a question. Yes?
I love the way it's completely separated from applications. Is there any enrichment of the HTTP error codes or the HTTP headers so that they can do fallback or know that Istio has done something?
So it doesn't enrich, but it can handle faults for you. So you can set, like, for example, retries within Istio and say, this microservice you can retry 3 times, and when you see a certain HTTP code, it will try 3 times for you, so you don't have to do it in your application code. So
can the application tell that occurred?
No, that will be handled like transparently by Istio. That's the point, right? Like you let Istio handle that kind of stuff. But if you want your application to know that, then you would let your application handle it.
Just a standard HTTP error standard.
Yeah. Yep. All right. Thanks very much again.